Hi everyone, my name is Abel Grey Katoma. I'm from GREYTEST Design Consults. This is my WhatsApp contact. You can reach me on this number or you can call me on any of these numbers, okay? Today I'm going to be showing you how to design your hidden beam, okay, in Protastructure. As you know, your hidden beams are beams that are actually inside your slab, that is beam in slab. These are beams that are inside the slab, so it takes the depth of that particular slab whereby you don't see that particular slab, okay? But in actual sense, hidden beams are actually what we call the slab stiffness, okay? So they are slab stiffness, just to increase the stiffness of your slab, okay? So the slab stiffness, okay? So let's come back to this. Now let's say that the depth of our beam in the Protastructure itself is actually 600, and then the width of that particular beam is actually 230. So but we also want to have a beam that is actually here, probably maybe because of the width of this particular slab is wide, okay, and then let's say there is a deflection there and then it's failing, okay. So if that particular slab is failing, we can introduce a particular hidden beam, which is the slab stiffness, in order for it to increase the stiffness there, okay. So in that case, to introduce this kind of a beam, all we need to do is to, sorry, let me turn off this interrogation beam display. Okay, I think it's in story 0. I have to go to story 0. I see that it's reflecting here and I don't want that. Okay, nice. So let me come to my story 1. Okay, nice. Okay, it's looking a bit clean now. I can hide some of this. Okay, in order not to waste too much of our time, okay, let's come back to the business of the day. To do this now, all I need to do, because I said I'm going to be using, if the building itself, for example, is 230 by 600 depth, okay, and I want to maintain that, but I want to introduce that particular hidden beam inside here, okay. So for me to introduce that, because our floor beams are 230 by 600 and I want to, for example, maintain that here, in order for me to calculate that, how do I calculate that for this here? So all I need to do is to come here now, since I know that my floor beams are 600 by 230, if I multiply that, is going to give me the area of each of the cross section of this particular beam, okay. So if you take that cross section, to know the area is to multiply 600 by 230. It's going to give us 1000, it's going to give us 138,000, okay, in millimeter square, okay. So but you know that your area is depth times breadth, or length times breadth, or whichever way you want to call it, okay. So if that is correct, now if I divide this one now, which I have as 138,000 divided by 200. Now, assuming that the thickness of my slab that I'm using for this design is 200, for example. Now if the thickness of that slab is actually 200, I'm going to divide the area of this particular slab divided by the thickness of that particular slab. Okay, so if I do that math, it's going to give us 690, okay, which is telling us the width. Okay, this is in meter square, this is actually in meter. Okay, so if you do that math, it's going to take out one of this particular meter, millimeter. Okay, so millimeter will take out one of the millimeter, it becomes 690 millimeter. Okay, so if I have 690 now, you know that this will now therefore be the width of our beam. Okay, so 690 will now be the width of this beam. So if you multiply 690 multiply by 200, it will still bring you back to 600 by 230. So what this is telling us is that the area for this particular beam and the area for this particular beam is actually the same, only that in this case this is actually rotated the other way around. Okay, so if that is correct, so the deep part of this particular beam is actually our 200, and then the width of this particular beam is 690, while in this other beam the depth of this particular beam is 600, while the width of this particular beam is 230. But in real sense, you know that this particular beam will give you a better result than this. So this is 100 times better than what we have here. Okay, but like I said, this is actually a slab stiffener. Okay, so there are designs that you may actually want to introduce this particular type of slab stiffeners in them. Okay, so what this is trying to tell us now is that you cannot go less than 690 width. Okay, so you can decide to adopt a wider, okay, but you cannot go less than this particular width. Okay, so to introduce that to our design, all I need to do is to come back to my Protastructure here, and then I will come to my beam. So if I click on beam here now, the width, which is the breadth, is going to be 690, and then the depth of this particular beam is going to be 200. Okay, so once I do that, I already have an axis here at this point, assuming this is where I want to introduce this particular beam. Nice. So you can see what I have here now. I have 690 by 200 size of beam. So I can as well delete the slab that is here and introduce another slab. Okay, so I can take out whatever I have here, all these slab strippings, and introduce another slab strip. Okay, you can see this is already a complete design that I have done before. I'm just introducing this beam in an existing design. Okay, so this is my beam. All I need to do now is to insert a slab here, insert another slab here, and that is all. So this is exactly how to achieve your beam in slab. Okay, so if you love what you are seeing, make sure you like this video, give it a thumbs up, subscribe to this channel. It's actually free. Click on the bell icon so as for you to get a notification whenever I post videos. I post videos like this on a weekly, sometimes on a daily, just to encourage as many that actually want to have a deeper insight of design. Okay, so make sure you stay safe and make sure you stay blessed. So you can see I have successfully inserted my slab in this, and I also have my stiffener here, which is actually here as my beam 52, okay, which is 690 by 200. So by the time you analyze and you design, you'll be able to see this particular beam among your design.